Hello, algebra-teers. Welcome to section 4.2, the standard form for a quadratic. Hopefully, you had some practice graphing quadratics. If you need to, you can always go back and look at the video that I did before so you can figure out how to graph those suckers. But we had a particular form we were graphing from that was called vertex form. And that's a wonderful form to graph from, and it makes perfect sense when you're graphing it from that form. However, that's not the form you're usually given. So for today, we got to talk about graphing a different form, which we call the standard form. Why would we want to do that? Well, like I said before, quadratic functions are usually in this form, and we should be able to graph from this form as well. Because in the real world, if we ever had any models of activity that looked like a parabola, we would know that they're quadratic function, and we could come up with the quadratic function for that information. By the way, if you're looking for like some use for quadratics in physics, if you take physics ever, you'll find out that most objects, well, let's just say most objects in our visible universe can be, their motion can kind of be described with quadratics. So anytime you look at the path of objects in a field of gravity, you're going to see a parabola. Think about it for a second. I mean, let's play basketball. If you're shooting, right, you shoot the basketball, what path does that basketball take? It takes the path of a parabola. It goes up and then it comes down, and hopefully it comes down and goes through the hoop. But any object that is thrown up into the air will follow a parabolic path. So when we're trying to predict things like, I wonder where this is going to go, mathematicians for 2,000 years have used quadratics. They didn't use it 2,000 years ago. They actually did. They would hire mathematicians. Kings and armies would hire mathematicians to sit down and calculate what were called ballistics tables. And so even way back when they were making trebuchets, they wanted to know where the thing was going to land once they shot it. And so they would take out their ballistic table, which was calculated by mathematicians using quadratics, just like you're going to start using here. And they could tell you like where that object they launched was going to fall. And later on, when they invented gunpowder and started shooting guns, they hired even more mathematicians so they could figure out just how far their gun could shoot. And they still use them. Like if you go out on the field of battle, you might have like a little computer right now, but even the computer is calculating ballistics tables and trajectories based on these parabolas, these quadratics. Input a little bit of information into your quadratic. It'll tell you where your ammunition is going to land, whether you're firing a rifle, a cannon, a mortar shell, trebuchet, which is like a catapult, any of those things. Even if you're just throwing something, we can calculate where it's going to land. Anyways, back to actually maybe drawing some of these things. Standard form is something that looks like this. So you've got f of x equal to ax squared plus bx plus c, as opposed to what we were looking at before when we said basically f of x is equal to a times the quantity x minus h squared plus k. This would be considered vertex form. We'll get into that later, even though you already know how to use it. But we're going to talk about quadratics that are in what's called standard form, and they look like this. So for example, here's a quadratic in standard form. Notice that a is 2, b is 8, and c is -2. All right? This is the standard form for a quadratic. Now, here's what you're going to need to know. This is the magic piece that you need for this chapter. Are you ready? I'm giving you the magic right here. Here's the magic. -b over 2a. Okay, this is the magic piece. And it's magic because in vertex form, we were able to glean where the vertex was just by looking at values for H and K. But for our standard form, we can't glean those values. But what we can say is that a negative b over 2a is actually going to be our h. Okay? That's going to be the x coordinate of the vertex. Just like before when we said h is the x coordinate of the vertex here, negative b over 2a will give us our h. All right? So let's plug in these numbers and see what we get. 8 is our b, so I'm going to go negative 8 over, because remember I'm doing a negative b over 2a. So our negative b over 2a is negative 8 over 2 times our a, and our a was 2. So negative b over 2a is going to be negative 8 over 4. We could reduce that, because negative 8 divided by 4 is, yes, that's right, it's negative 2. So what does that mean? Well, that means my h is negative 2. See, that's not so hard. We already know what our h is. I wonder how we find our k. That would be the y value for our vertex, because h, remember, is the x value of our vertex. K was the y value of our vertex, with our vertex at h, k, right? So we found our h value. How do we find our k value? Well, there's just no easy way. What we're going to do is say our k value is going to be equal to, I'm just plugging in my h. In this case, 2 times negative 2 squared, right? Plus 8 times negative 2 minus 2. Now, what did I just do? Well, I took this negative 2, that's my h, and I plugged it in here and here. I plugged it in for my x values here and here. So this is 2 times negative 2 squared. That comes directly from up here. 2 times negative 2 squared plus 8 times negative 2, and then minus 2. So I'm just plugging in negative 2 wherever my x was up here. Okay? Why am I doing that? Because I'm looking for k. I get my k by plugging this value in for my x. All right? For plugging, I just take my negative b over 2a and I plug it in where my x's are, and that'll give me my k. So let's do this. Negative 2 squared is 4. It's not negative 4. I've tried to tell people that for years. When you square a negative, you get a positive. So anyways, if I take a negative 2 and square it, I get a positive 4 times 2 is 8. Then I take 8 times negative 2, and that's a negative 16. So this is 8 minus 16, and then I'm still subtracting 2. I'm just simplifying from above. 2 times negative 2 squared is 8. And 8 times negative 2 is negative 16, and I'm still subtracting 2. So let's do the math on that. That would be like negative 10, correct? Yes, negative 10. Okay, so I just found my k. My k is negative 10. So my vertex, which always lives at hk, is going to be at negative 2, negative 10. Okay? My vertex is at negative 2, negative 10, because the magic is right here. This is the magic. You got to remember the magic thing for the entire chapter. We're going to be given parabolas most of the time in standard form. They're going to be in this form. So you're going to get problems that look like y is equal to 2x squared plus 8x minus 2. And just by looking at it, I don't know where the vertex is. But if I use my magic, a little bit of mojo here, I use my magic to find my h, then I can plug my h back into the original equation to get my k. And once I know my h and my k, and then I'll know where the vertex is. That's the magic that's happening there, okay? So what does this look like? Well, let's draw a graph, shall we? Oh, by the way, let's say that you're stuck at home because COVID has knocked everybody out of school, and we've said, you can't come here and steal Mr. Fokin's graph paper. But if you don't have the opportunity to go to town and you don't have graph paper at home, can you make graphs yourself? And the answer is yes, but keep in mind, I was telling a different class this. Actually, I've told two different classes this. I get, and you'll laugh, but it's like I get pictures like this. They're like, here's my graph. I don't even know what this is, but it's like they think they can draw straight. So they draw some curve here and they label it Y-ish. And then they draw some curve here thinking it's straight and they label that X-ish. And then they start plotting points on there and they connect them with what they think are straight lines. And I get the goofiest looking things, and people are like, well, that's my graph. Nah, that's not really a graph, because we use graphs so that we have a nice picture of what's going on. Can you imagine, like, if you hired a photographer to take pictures of an important event, and when you got the pictures back, they were all blurry or they were focused on the wrong thing, and they're like, what? I took pictures? You wouldn't be happy with that. That's not acceptable. So what you want to do in your math problems, if you don't have graph paper, is you can make your own coordinate system. What you're going to do is use your straight edge. And I know in the past I've said, we don't use the markings on our ruler in math. And that's generally true. But in the case of having to make our own graph paper, you're welcome to use the markings on your ruler. So what you can do, and what I've done on this particular picture, is I use my straight edge to make the line, but then I mark off every half centimeter, okay? Because that's going to kind of become my grid. So I just put marks down all the way along this line, right? And then I matched up the number right on the number with the axis, right? And I marked off every half centimeter along that axis as well in both directions. So when I'm done, I have maybe not grid paper, but I do have the ability to put particular points down. For example, if I wanted to graph the point 2,4, I know I go over to the second mark here and up to the fourth mark here and put my dot. And that's actually pretty accurate, even when you don't have graph paper. So you can make your own graph paper with a ruler. It doesn't take really much longer than it does to just draw one of these on your paper like I'm doing now. It's just a little bit more convenient when you have a grid, because you can place your ruler along the line that already exists. But it'll work just fine even if you don't have graph paper. So as long as you have a ruler at home, and I think most of us have a ruler, you can make your own graph paper even though you're stuck in COVID time without it. So I'm going to make a graph here to graph our function that I had up here. It was y is equal to 2x squared plus 8x minus 2. And I went through my magic to find that my vertex is at -2, -10. So I'm going to go to my graph, to -2, -10, and I'm going to put a dot. Okay. Now, that's by vertex. It's at -2, -10. I had figured that out from before. But how do we know where to go from there? Well, recall that when we were looking at vertex form, A was the indication of where my next points are going to go. And it serves exactly the same purpose in standard form. So A is the number that comes in front of the x squared term. In this case, our A is 2. And our pattern, remember, was 1A, 3A, 5A, and so on, right? We're going to take each odd number times the number A to figure out where we go. So from my vertex, just like we were doing before, since A is 1, 1A is going to be 2, 3A is going to be 6, 5A is going to be 10. I may not get that far, but these are the places where my points would go. From the vertex, I always go over by 1. It's always over by 1. You're going to get tired of hearing me say that, but you know what? It's always over by 1 when we're talking about quadratics. You're always going over by 1. You don't go over by any other number. You go over by 1 always. So from here, I'm going to go over by 1, and I'm going to go up by 2 because that's my first number. So over by 1, up by 2, and put a point. While I'm down here, I'm going to go over by 1 in the other direction and up by 2 as well, because you always go over by 1, and then you go up or down by these numbers, right? So from here, how far am I going to go over? 1. It's always over by 1, and then I'm going to go up by 6. So over by 1 and up by 1, 2, 3, 4, 5, 6. There's my other point. Same thing happens over on this side. You go over by 1. You always go over by 1. And then you go up by 1, 2, 3, 4, 5, 6. And there's my other point. Now, from here, I could go over by 1 and up by 10. I'm not going to get that far because that's going to go off my paper. But I can connect these dots. Remember, it's a parabola. Parabolas are U-shaped things. Sometimes people start making V's. Parabolas are not V's. They are curvier, okay? So you want to make sure that no matter how skinny they get, you're still showing like a little bit of curve here. I look like I'm an old person with Parkinson's. I'm shaking as I draw this. No, if yours is a little bit wobbly like mine, that's okay, as long as you can kind of see that the overall picture is that this is a parabola and that you have these points marked off so you know how skinny your parabola is and where it's going. Okay, make sure you mark off the correct number of spaces. That's it. That is the magic that makes all of this happen. That's how you do the graphs for these. Okay? Want to see magic part 2? Yes, show us magic part 2. Okay, magic part 2. Here's a question you might see. It'll say like, oh, y is equal to 2x squared plus 10x plus 7. Okay. Magic part 2. The directions here are going to say like, what is the vertex form of this? And the vertex form from the previous lesson, vertex form, would be easy to write if we knew what? Well, all we really need to know is h and k, because I'm going to write y is equal to 2, because that's a, right? I mean, a is a times x, and I'm going to put a blank here, squared plus blank. If I knew h and k, I'd be in vertex form, because vertex form is y is equal to a times x minus h, quantity squared, plus k. All I have to do is figure out what h is and what k is, and I'm golden. But I know how to find those because I gave you the magic earlier. Here's the magic. It's right here. This is the magic right here. We got to use the magic, and we'll know what it is. So down here, I'm going to use the magic. I'm going to go, okay, negative b over 2a. The magic is going to happen right here. Is that I'm going to read from my equation what b is, and I'm going to go, okay, it's a negative b over 2 times a, because that is going to give me my h, remember? So let's do the math here. 2 times 2 is 4. That's negative 10 over 4, which we call negative 5 halves, right? So my h is negative 5 halves. I'm subtracting negative 5 halves. If I subtract a negative, I'm saying plus 5 halves here, right? Does that make sense? Yes, Mr. Foken, that makes perfect sense. Okay, good. Now, what was the second part of our magic? What we did after we found our magic, which is our h, right? After we found our h, we plugged our h value into the original expression or equation everywhere we saw an x, because to find our k, we're just going to plug that h value that we found in to our equation, okay? So in other words, what we're going to do here is we're going to say, here's my original expression. I'm going to go, hey, k can be found, excuse me, k can be found by taking, in this case, 2 times negative 5 halves squared, right? Just replacing my x with negative 5 halves, plus 10 times negative 5 halves. Again, we're just replacing the x there, plus 7, okay? So we can find our k value. That's the last thing we need, and we'll plug it in over here just by plugging in our h value in for x. So here we go. Negative 5 halves squared is going to be 25 fourths. When you square negative 5 halves, you're going to get positive 25 fourths. And then I'm going to add to that 10 times negative 5 halves. Well, when you take 10 times negative 5 halves, you're going to get a negative 25. And then we're going to add 7. Okay, so let's do some more math here. Let's do a little bit of arithmetic. When I do this, I'm going to get 25 halves minus 25 plus 7 is going to give me what? Negative 18, right? So I'm going to get 25 halves minus 18. And if I leave everything in terms of fractions, I'll just keep going to the side here. 18 in terms of halves is like 36 halves. So this is 25 minus 36 all over 2. What's 25 minus 36? Was that 11? Oops. Figure out how to turn my calculator on. The toughest part of the day, figuring out how to turn on my calculator. So that's going to give me, gosh, my picture's in the way now. This is going to give me negative 11 halves. So I'm going to fill that back up in here. If you wanted to say plus a negative 11 halves, I'll let you get by with that, you slackers now. But I'm going to say minus 11 halves here. Okay, so this is the vertex form for our original expression. All we have to do is find our h and our k, and heck, we know how to do that because the previous example showed us use the magic to find h, plug your magic in to find your k, okay? Same thing happened here. We used our magic. There's our magic, our mojo. There it is. We're going to use that to find our h, and then I didn't say that's equal to h, but I should have. That's going to be our h, and then we're going to find our k by plugging that number in for x back into the equation to find our k. Write it in vertex form. Vertex form, again, is a times x minus h squared plus k. Groovy. Now, I'm going to go back to this groovy first equation that we graphed, and you might get a question there that says all of these things. It's going to be confusing because it's going to say, hey, what's the vertex? Well, the vertex is at hk, so that's not so bad. But if you're asked to label what the vertex is, you're going to have to say, now remember our vertex from before, we calculated it out. It was at -2, -10. And so then we came over here to -2, 10, and we put the dot where the vertex is. So the vertex was at -2, -10. That's where the vertex is. But it might also say, give the axis of symmetry. What's that, Mr. Foken? Well, the axis of symmetry is the line that you could fold this function over and it would be the same, So we take this and fold it over that and we get the same branch on either side. This is the axis of symmetry. So it's a line that goes up and down. We call that a vertical line. And so that's always going to be an equation. That's going to, for the axis of symmetry, it's always going to be equation x is equal to some value. And so that value is always going to be h. It's x equals h is going to give you your axis of symmetry. So for this particular problem, h was -2. So the line x equals -2 is my axis of symmetry. It's just that simple. X is going to be equal to your h value. That's the equation of the axis of symmetry. It sure seems like, then it might say like, is there a minimum or a maximum value? And I think we kind of touched on this before. If you look at this function that we graphed, the arrows that I put on the end here mean it just keeps going up and up and up and up and up. So there's no maximum value. When we're talking about maximum or minimum values, we're saying, these are, the y values. And since there's arrows here, it just keeps going up. There's no maximum y value, but there is a minimum one that's down here at the vertex. So your minimum or maximum value are always going to be the y value of the vertex. In other words, k. All right. So when it says max or min, you're going to have to choose if it's a maximum or minimum value. And for this graph right here, the minimum value is at -10. That's your k value. That's as small as it's ever going to get in the y direction. So this actually has a min, which is -10. That function will never get smaller than -10. Thought I'd better cover that real quick. They're pretty straightforward things, but you might be asked, what's the vertex? What's the axis of symmetry? The axis of symmetry is always the equation x equals h. Just fill in your h value. So in this case, h was -2. Plug that in there. And then you might be asked for a maximum or minimum value, and that's going to be the y value or the k, because that's where the lowest or highest point of it is. If your parabola opens upward, there is no maximum value, but there will be a minimum value. On the other hand, suppose you had a parabola that pointed down like that, then the vertex represents the top, its peak value or a maximum value, and that's still just going to be k. You just have to recognize that if it opens downwards, you'll have a maximum value. If it opens upwards, you're going to have a minimum value, and you just say that value of k is either the max or the minimum. Okay, so good luck to you. Your homework assignment is posted. Have a great day. Hopefully we'll be talking at you soon. Bye-bye.